Welcome to lesson 94. In this lesson, we're going to find a new strategy for solving systems of equations aside from graphing. We're going to use elimination. And that means we're going to see us do a few things. One, can we express equations in standard and y-intercept form? Can we fluidly move back and forth? That's going to be really helpful because they both have to be in the same form in order to eliminate x or y. Then this is where it gets interesting. A lot of great thinking work and so many options. You're going to identify if any pair of x and y can be eliminated when adding. You're going to look for zero pairs. You're going to look for opposites so that when you add them up, they will turn to a zero, eliminating x or y. And if there aren't any, you get to use multiplication to create zero pairs. So watch how I do that in this next model. Then we're going to use substitution to find the value of the unknown variable and express the solution as an ordered pair, or recognize when there is no solution. What does that look like algebraically if I have zero or infinite solutions? Let's look at a new strategy for solving a system of equations. We're going to look at it when we have one solution, all solutions, infinite, and no solutions. So here we know we have a one solution, meaning we already know it intersects. I'm just using this as a visual so we can see it. To eliminate means we're going to solve really by eliminating either x or y's. We're going to create that zero pair. So what does this look like? All right, I'm going to use our two equations. I'm going to write my second equation. And imagine I'm adding these two together. Now, if I were to add them as is, I would just end up with 2y is equal to negative x plus 6. But our goal is to somehow eliminate one of these equations. And when we eliminate them, we can solve for the other. So if there was a way to eliminate this x, I could solve for y. That's going to be our goal. So looking at these two numbers, is there any way that I can create a zero pair the way they are? No. So I'm going to use multiplication to create a new equation that is still equivalent that will have a zero pair. So looking here, looking right here and right here, what if there was a 2 in front of this x? If there was a positive 2, I could eliminate these. So that's one option. So I'm going to do just that. I'm going to multiply this entire equation by 2. Now I'm going to have this. Let me write my first equation just so that it's still in front. So my second equation is now 2y is equal to 2x plus 6. Now when you add them up, I'm going to get 3y is equal to, these are eliminated, it's happened, it's equal to 9. I can solve for y now. Now that I've eliminated the x, I can solve for y. And y is equal to 3. And just why I do have the graph here was when we used earlier, you can see that my y coordinate is 3 for the solution. You're not always going to have the graph though. I just want to show that it's true. So now I'm going to take that 3 and I'm going to substitute. Okay, so let's go into the very first equation. Y equals x plus 3. 3 is equal to x plus 3. Now I can solve for x. 0 is equal to x. So now I know my x coordinate is 0. And so my solution is 0, 3. How do I know it's not 3, 0? Because my x is equal to 0 and my y is equal to 3. So here's my solution. And just to verify, I'm going to do the other equation as well. Y is equal to negative 2x plus 3. 3 is equal to negative 2x plus 3. I want to move that 3 over. 0 is equal to negative 2x. I can divide by negative 2, divide by negative 2, x is equal to 0. So I still get the exact same solution. Hit pause and jot this down into your notes. Now we're going to look at a second one. As you can see here, our work of elimination does have a point at 0, 3. But what's going to happen when we have no solution? So we could already see our two lines are not intersecting. So what if we tried elimination in this case? Y is equal to 3x. Y is equal to 3x minus 2. I want to add them. I still want to create a 0 pair. I'm going to put a plus 0 here just to have it balanced. And just looking at it, I need to turn one of the equations negative. So I'm just going to multiply just the top one. I'm going to multiply it by negative 1. Okay, so here's my new equation now. And pretend I'm distributing. Negative y is equal to negative 3x plus 0. Y is equal to 3x plus 2. So what happens when I add these two equations? Well, turns out I eliminate the y's and the x's, and I just end up with a 2. So here's the problem. There is no solution here. Absolutely none. 0 is equal to, in this case, 0 plus 2, or 0 is equal to 2. That is not true. This is not a solution. So this tells me there are no solutions. And again, this is a case where, let's say you were solving with elimination and you didn't do a check first. Now, to be fair, we know that they both have the same slope. We can see it. They both have a slope of 3, m equals 3. And we know that the b's are different, where b equals 0 and b equals negative 2. So I already know just from looking at the equation that these are going to be parallel lines. But I just wanted to also show you what happens when you try to solve this equation with elimination. As you can see, I have no solution. This is not a valid equation. Hit pause and jot this down in your notes. And let's try one more. What happens when you have infinite solutions? So same thing. Y plus 2 is equal to 2x. And here's my blue. Y is equal to 2x minus 1. I do need them in the same form, so I'm going to distribute here and here, and I get y is equal to 2x minus 2. Okay, one is in y-intercept form, one is not, so let's put them both into y-intercept form just to make it easier. Y plus 2 equals 2x. I subtract 2 on both sides. Y is equal to 2x minus 2. All right, what do you see, math marbles? What are you noticing about these two equations? They're exactly the same. They're absolutely exactly the same. I'm just going to multiply one of them by negative 1. Because I see this. And so I already know that's my big hint that they're the same line. That there's going to be infinite solutions. But let's say you don't see that. You don't recognize it. It's just not happening in your head. All right. Let's say we multiply this one by negative 1. Now what do I have as my equations? Now I have negative y is equal to negative 2x plus 2. And I have y is equal to 2x minus 2. And when you add all of these up, what are you going to get? 0 is equal to 0 plus 0. So I end up with 0 equals 0, which is just like a reflection of itself. So this is my clue that this is infinite. Okay, so if you end up with a solution like 1 equals 1 or 0 equals 0 or 8 equals 8, then you just know that you have infinite solutions. But there are tons of clues here beforehand. One is by recognizing if they have the same slope and the same intercept, then you know they are the same line. So that should be your first hint that you're going to have infinite solutions that are exactly the same line. And that's what we're seeing here. So hit pause and jot this down. And now you know what happens with elimination. What happens when you algebraically try to eliminate one of the terms. If you have a term like this, 0 equals 0, you know it is infinite. If you have a solution that does not make any sense, like 0 equals 2, that does not make sense, is not valid, then you have no solutions. You have two parallel lines. And if you're able to actually solve for one variable and then get the second, then you have one point of intersection. Our first model today is pretty straightforward. I'm going to solve the system of equations using elimination. There are not many other ways to restate that. In terms of facts, I have two equations and I'm going to look for opportunities to eliminate x or y with their opposites. So here's my plan. Looking at it, there are no terms that are the same. I don't have any zero pairs, but I can eliminate y. There's something I can do there. I'm going to multiply the equation 2x minus 2y equals negative 10 by 4. Because when I do that, I'm going to get a negative 8y. And that is the zero pair I want. That way, when I add the two equations, I can eliminate those y terms. And this will allow me to solve for x. When I am solving for x, this is what's going to help determine if I have 0, 1, or infinite solutions. If x equals a number, there's one solution, and I'm going to keep going to find y. If both sides are equal, like x equals x or 5 equals 5, I have infinite solutions. If the equation is false and untrue, like 3 equals 2, no solutions. So if I have a solution, I get x equals some number, I'm going to substitute x into an original equation and solve for y. And then I'm going to check my solution into both equations. So hit pause so you can jot this plan down into your notes. All right, so let's look at our original equations that we have here. And they're both written in standard form, which is good. I can stack them on top of each other. Notice that I can't eliminate either x or y the way they stand. So one of the easy things I notice is I have an 8 here and a negative 2 here. What if I multiplied this by 4? That way I would have a negative 8. That's what I want. So I'm looking for ways. Is there a quick way that I can multiply one of the equations to make a zero pair? With these two, I would have to multiply both because their common multiple will be 6. So I would have to multiply this by 2 and maybe this one by negative 3. That would be the only way that one works. But here, I don't have to. I can just multiply this one so that I can create a zero pair. So I'm going to multiply this by 4. And my new equation is 8x minus 8y is equal to minus 40. So now let me put my two equations side by side. I want to give myself plenty of space. And I'm going to add both together. And I get 11x. This is a 0, is equal to negative 33. And I'm just going to isolate for x. X is equal to negative 3. So I have the first half of the solution. So now that I have this, this is where I'm going to make a substitution. So I'm going to choose one of the equations. 3x plus 8y equals 7. So 3 times negative 3 plus 8y equals 7. And I'm going to solve for y. And I get y is equal to 2. So now I have my x and I have my y. So my solution is -3, 2. There's my solution. I do want to check it algebraically, so let's do a quick check. That means I'm going to substitute into both. Now I get -9 plus 16 equals 7, and yes, -9 plus 16 is 7. So valid solution for the first equation. I'll try the second, and I can use the original. And I get -6 minus 4 is equal to -10, and that one is also valid. -10 is equal to -10. So our solution, -3, 2, that is a solution to the system of equations. And that's it. Hit pause and jot this down into your notes. The major takeaways, basically, one, I'm looking for a zero pair. That's the very first thing I want to identify. How do I create the zero pair? I'm looking for a common multiple that is just its opposite. Once I have that, I can use the zero pair to solve for the other variable. And when I have that, I will sub it into the other equation to find the other variable in the problem. And I always check my work.